Hello, welcome to our semiconductor education program. I'm Vincent Chang. In this lecture, I'm going to teach you about the AC analysis, the gain calculation of IC power amplifier. So if you can remember, in the previous video, I have taught you about the DC analysis of the IC power amplifier. So here's the IC power amplifier, the LM380. So you have the input stage, gain stage, and the output stage, and on the top is the bias. So before we conduct the AC analysis, we have to draw sketch out the AC analysis circuit, the AC circuit, AC equivalent circuit. So let's start with the input differential pair, the Q3, Q4, and the one external emitter resistance R3. And then the two input emitter follower, Q1 and the Q2. So emitter follower, differential pair. So all the symbols on this diagram is the AC. For example, the VE3 is the AC emitter voltage of Q3. The I4 is the AC collector current. The I4 is AC current. And then on the left, the base terminal of Q1 is the AC ground. So remember, on the right, the base terminal of Q2 is the non-inverting terminal. All right, so the VI, the input signal, is actually between the non-inverting and the inverting terminal. So VI is the differential AC input signal. So if you can remember, there is a bypass capacitance CB, right? So when you conduct the AC analysis, you have to short circuit the bypass capacitance. So the emitter of Q3, between the resistance between the emitter of the Q3, the VE3, the E3 and the ground, the AC ground, is half of the R1. And on the bottom, so we have the current mirror, right? Q5, Q6 current mirror. And then we can, at this point, we can put the gain of the second stage, the common emitter, the stage, as because it's the inverting. Common emitter is the inverting out of phase. So it's a negative mu. The magnitude of the common emitter stage gain is mu. And also there's an important feedback resistance connecting between, remember, the output terminal and the input stage. The differential input stage is the R2. The feedback AC current is the IF. So here's the data sheet. One of the features is the voltage gain is fixed at 50. Which is equivalent to 34 decibel. So voltage gain is defined by VO AC output voltage divided by AC input voltage VI. So single ended out divided by differential in, according to data sheet, is 50. So now I want you to stop and think how to solve this AC diagram. How to solve this AC diagram by yourself. So you can pause, you can stop for try to 5 to 10 minutes, try to solve this AC equivalent circuit by yourself. At least you need to think about, maybe you cannot solve the whole thing, right? But at least you try to solve where to start. Where to start? The differential, right? So the differential, the input differential, at least you have to try the differential. What's the key skill to solve the differential amplifier? When it comes to the AC analysis, what's the key skill that you learned before? So try to apply what you learned before and solve the differential, and and then if you can solve the differential, go to the feedback. Let's pause for at least 5 minutes. All right, time is up. So can you get the emitter current of the differential amplifier? So input differential amplifier. Input differential amplifier. So let's start with the input differential AC analysis. The skill you learned before in the previous video, previous lecture about the differential amplifier, the I3, the focus on the emitter. So the I3, so why this way? Why this way? Why this direction? Why? You can also go this direction, right? But if you go this direction, it will be out of phase of the VI. So, because the VI is from the right? So go this direction will be in phase associated with the output signal, right? It's easier. So I3, so what's the I3? Folks, start with the emitter. The emitter, and then what? Ohm's law, and then in phase, direction in phase. Let's do it again. The emitter perspective, the total resistance looking into emitter, and then Ohm's law, and then direction. So here's is the I3. So this direction, right? This is should be clockwise. So this should be the counterclockwise. Counterclockwise. So from 3 o'clock to 9 o'clock. So total resistance in the emitter. So what's the total resistance? External one, R3. And then emitter perspective, the internal emitter, so looking into the emitter. So this is the RE4, this is RE3. So RE4, R3, and then RE3, right? Right? So R3, RE4, and then RE3. And then what? You have the another emitter resistance of the input emitter follower, IE1 and IE2. But it's the base. The emitter of Q2 is the base of Q4. So we focus on the emitter. So for the perspective of base, for the base should be reflect back to the emitter divided by 1 plus beta, right? So this, unveil this. So RE1, RE2, right? It's the base of Q3, Q4. So you have to reflect back to divide by 1 plus beta back to the emitter of the differential. So here's the first step, the I3, you have to get this right. But the R3, of course, is much, much greater than the rest of the emitter resistance, not to mention the divided by 1 plus beta 1. So you can neglect the 4 items, the 4 small emitter resistance, and get this one. And get this one. So VI divided by R3. All right? Are you with me? So now let's move forward. So what's next? So the next will be because we neglect the 4 items. So which means what? We neglect the voltage dropped across these 4 small emitter resistance, right? So then the blue node, the first blue node, should be approximately equal to AC ground. So by the same token, the second blue terminal should be approximately equal to what? Equal to VI. Because we neglect the 4 resistance, the 4 voltage drop, which means the total differential is going to fully, approximately, completely drop on the external resistance R3, so VI. And then you can get this. So because the I3 is equal to, approximately equal to I5, and the current mirror, and the I6. Again, let's do it again. So I3 and I5 and mirror 6. So 3, 5, mirror 6. So IC, so you get I6, VI divided by I3. Let's move on to the second stage. So the second stage, let's focus on the feedback. The feedback. So the feedback current should be what? VO Ohm's law divided by minus VI divided by R2 Ohm's law. And then we can move forward to the blue node, right? Emitter of the Q4. And then based on the KCL, so the I4 is IF minus I3. So we're almost done. So IF, we got IF, I3. Yeah, that's the first thing we got when we analyzed the differential. So IF, I3, and try to link the I4. I4 is what? I4 is almost equal to I6. I6 is I3. Get it? Get it? So if we neglect this current, why this current can be negligible? Why? Because it's the base current of the common emitter amplifier. So the base current we neglect. So I4 equals I6. So 4 equals 6, 6 equals 5, 5 equals 3. So you can substitute I4 with, we can substitute I4 with what? With I3. So I3 is the VI divided by R3. Let's look at it again. Let's look at this again. So VI divided by R3 represent I4. And then IF minus I3. So then the answer is this. The answer is this, 51. So more accurate solution for the AC voltage gain is 51. So this proves one of the feature on the data sheet. The voltage gain is fixed at 50. And if you express this as a log scale, on the log scale is the 34 decibel. So here's the takeaway. Here's the takeaway. The first one. So let's stop and reflect what have we learned so far. The first takeaway, input differential amplifier. So focus on the emitter, right? The emitter current, the emitter resistance, Ohm's law, and also the direction. Right? You get this, the direction. And then this two blue node tells us the voltage drop across the R3 is almost the same as the external input differential signal. And then 3, 5, 6. 3, 5, 6. And then what? Feedback current. The second takeaway, the feedback current. The first takeaway, you try to solve the input differential and then move on to the second stage. The feedback is the key. So the feedback current, VO minus VI divided by R2. And then we move on to the blue node. And based on the KCL, the relationship between the three current, you can get the final result. You can get the final result. The VO, you can put the VO, link the VO and the VI together. So I hope you learn the skill. Although it looks a little bit overwhelmed, intimidated at first sight, but finally we made it. And I hope you also learned something from today's lecture. Thanks for watching.